this video, we're going to look at some examples of end behavior. And we're just going to determine what the end behavior would be based on what we know about the polynomial. So for example, if I have f of x is equal to an x squared plus 2x minus 5. Well, let's look at what all we know about this function. We know what its leading coefficient is. Its leading coefficient, this is in standard format, so its leading coefficient would be a positive 1. The degree of this polynomial, since it is in standard format, we would look at the largest exponent. The degree would be 2. So if we talk about the end behavior of this polynomial, since our degree is even, that means it's going to go in the same direction, and it's positive, that means the right side of my graph is going to be up, and since I'm going in the same direction, the left side of my graph is going to be going up. So if I put it into the format like we did earlier, as x approaches negative infinity, so the left side of my graph, f of x approaches positive infinity. As x approaches, let me redo that. So as x approaches positive infinity, f of x also approaches positive infinity because they're both going up. Let's look at another example. H of x is equal to a negative x to the fourth plus x to the third plus a 2x squared. Okay, well, our leading coefficient in this case is actually a negative 1. Our degree in this case, largest exponent, is a 4. So since I have an even exponent, that tells me I'm going in the same direction for my end behavior. My end behavior, I have a negative leading coefficient that tells me I'm going down on the right side. I'm going the same direction, so I'm going down on the left side. So as x approaches negative infinity, f of x will also approach negative infinity. As x approaches positive infinity, f of x will also approach negative infinity because it's going down. Now I'm going to leave room because I'm actually going to come back to these two examples in a little bit in another video. And I'm going to go to, let's go to n of x is equal to a 2x to the third minus a 3x squared. So our leading coefficient in this case, where we're talking about leading coefficients, this one is still in standard format. So our leading coefficient would be a positive 2. Our degree is a 3. Our end behavior, so we have an odd, so we're going opposite directions. Our right side will be positive, so we'll be going up on this side, but we'll be going down on this side because we're going in opposite directions. And this 2 is telling me that we're going up on the right side. So as x approaches negative infinity, the left side, f of x will also approach negative infinity. As x approaches positive infinity, f of x will approach positive infinity. I want to look at one more where it is actually in factored format. Let's look at k of x is equal to a negative 3, let's go with 3x times x plus 4 times an x minus 2 times a 5x plus 3. Okay, this one, remember the leading coefficient and everything's a little bit different. So here, the leading coefficient, remember we have to take into account the leading terms of each factor. So we have a negative 3 times 1 times 1 times a 5. So that's going to give me a negative 15 for my leading coefficient. My degree, in this case, remember I take the exponents of each factor with a variable. So I have a 1 here, a 1 here, a 1, and a 1. So 1, 2, 3, 4. So my degree is 4. So my end behaviors, since this is even, they're going to be going the same direction. And this is negative, so that means they're both going down. So practice some of these end behaviors, and in the next couple of videos we're going to be implementing these end behaviors.